we developed a new methodology to monitor the cement production and so the economic activity more broadly in this paper. And not only in advanced economies, but we can do so for any country, at least when they have some cement plants. So today I'm gonna present some new results on cement production in emerging countries and developing countries. So let's maybe start with a quick reminder of what we've done. So cement is something very important, as it has already been said today, I think. It's actually the second most used material in the world, just after water, with about 5 billion of tons produced a year. And it's used in almost all economic sectors, mainly in the construction industry, but also for different kind of infrastructure. So it's very important for all economic sectors. So that's what made it a key element to monitor the construction industry and the economic activity in general. But the data is most of the time not available. For developing country, we can have official data, but with significant lags, but at least not in real time. And for most of developing countries or emerging countries, we just don't have any data at all. So to understand what we've done, it's important to understand how cement is made. So it just basically some raw material that goes through a chemical process, which is called calcination, which then synthesizes clinker, which is the main constituent of cement. And this calcination takes place in huge rotary kiln. That's some kind of big oven, as the one you can see on this picture. So they are very easy to identify, since, as you can see, it's very obviously where these kilns are. And to trigger the chemical reaction, it need to reach a temperature of 1,400 degrees Celsius, which is very, very hot. So that's what allows us to detect it through satellite data, and more specifically through infrared data. So we used the satellite Sentinel-2A and 2B from the European Space Agency, which have combined the two satellites, a mean revisit time of about 4 days. So each 4 days we can have an indication for every cement plant around the globe, whether this plant is producing or not. I'm gonna go quick through this, but basically we used some physics law to determine, by regarding the value of the emission of this on different infrared bands, to determine if an object is hot or not. And of course, that's the same for every data from satellites. We need to detect also clouds, because as you can see, it can interfere quite a lot with the thermal data. So we basically just compute a cloud coverage ratio for every image that we have, and just get rid of the data where there is too much clouds. So what do we obtain is the end is something quite like this. So this is a cement plant in Wuhan, so in China, the epicenter of COVID-19. We can see that in end of 2019, so just before the very big first COVID-19 outbreak, all the kilns, which are represented with the red dot, are hot, so are producing cement. That's why it's colored in red. Then in February 2020, that was during the COVID-19, all the kilns are cold. There is no heat emission at all. So the plant wasn't producing any cement at all. Everything was shut down. And then the production restarted from May 2020. So we can do this exercise for every cement plant and for every observation date. And at the end, we obtain a binary index for each kiln and each date, with a value of 1 if the plant is hot, so if the plant is if the kiln is producing some cement, or 0 if it's cold and so not producing. And finally, we aggregate this at the country level by using the capacity of each plant to weight the aggregation. And we obtain something, as you can see here for the US, so a daily activity index of the cement plants. So with a value each day that estimates the global activity of the cement plants in the country. So if you would like to have more details about it, you can go to the paper. There is the link directly on the slide. And then what we obtain is an index that is very powerful to estimate the actual cement production. So here is an example for the United States. So in blue, it's the official data, so the official cement production per month. And in orange, you can see our estimation based uniquely on our satellite data. So that's very accurate, and we can actually track it very well. So once we can estimate the production in cement, of course, we show that we're able to estimate also the activity in the construction industry. So to do so, we just compare a model with our satellite index to different benchmark models. And you can see that in most of the time, we either outperform the benchmark models or perform as well as the benchmark model, but with real-time data, which is already a very great advance compared to different kind of data, such as the PMIs or the building permits, for instance. And what can we see about emerging country through this data? So first, let's look at China, and more specifically China at the beginning of the COVID-19 crisis. So what we've done is that we take the satellite index for China, but split it in two different groups. One is the cement plants in the province of Hubei. That's the province where Wuhan is, so the epicenter of the COVID-19. And then the other group is all the other plants in China. And we normalize it by taking the mean of the series equal to 100. And finally, we just difference this both theory, and that's what's plotted on this graph. So the red area here corresponds to the first quarter of COVID, so starting in December up to the 1st of March. And the gray area corresponds to the exact same period of the year, but for the previous year. And what you can see is that usually during this period, the activity of the cement plants in the Hubei province is much higher than the average activity of other region of China. This could be explained most likely because of the weather there. So in winter in Wuhan, it's about 1 to 5 degrees Celsius, while it could be down to -5 degrees Celsius in Beijing, for instance. So that what could explain that the activity in the construction industry is higher in Hubei than in the rest of China. However, the year when the COVID happened, you can see that instead of having a spike as usual, the activity goes very, very low and very low below zero, with a difference of about from the top to the bottom of about -50 points on 100. So very important. And let's see what's happened in South Africa. So here you have just the satellite index, so monthly index, not the daily one. But we can see that up to this point, so up to end of 2018, it was quite usual every year the same, with the throughout about the same times. But we can see that there is some event that happened. The first one is here, and actually it corresponds to the beginning or the following of a crisis that happens in South Africa, an energy crisis, because the power plants in South Africa are quite old and not very, very reliable. So they need to prevent some damages on the network to just shut down to just cut the electricity in some part of the region. And this part here, so in March 2019, it corresponds to the first time where they need to apply a very important cut on the electricity network. since the beginning of our data. So we can see that we can actually detect it. Then later, this part, so the just before the COVID-19 period, this part corresponds to the worst outage level on record. So that means that at least 6 hours a day without power for most of South African people and for South African companies as well. So that explains why the production of cement was very low. And then for the rest of our sample, we can see that all that we can detect coincide quite very well with the COVID-19 events. So first, very important lockdown from March to April. So we can see this huge decrease in the cement production. Then, as of 1st May and later, we can see that there was a start of a gradual easing of lockdown restriction. And starting of the 1st of June, the restriction were lower even further. So that's what explained that the cement production reached a usual level. And then finally here, so from December to March 2021, there is a new lockdown caused by the second wave of COVID-19. Then here is the same from Nigeria. So what we observe first is that there is a huge decrease in the activity during the year 2016, and it actually corresponds to the first recession in over 2 decades, according to the World Bank, and that we can clearly see this huge decrease in the cement production. Then this small decrease in the production here correspond to the period during which there has been a major flooding in Nigeria, with 200 killed and more than 2 million people affected, according to the Red Cross. And we can actually once again detect this this decrease here in the satellite activity. And we can also study the impact of COVID-19 in Nigeria. So the red bar corresponds to the number of COVID-19 cases according to the WHO. And you can see that for each of these 3 main waves, you can see a huge decrease in the satellite activity of cement plants that coincide perfectly with the increase in the COVID-19 cases. And finally, we also try to look at a South American country, so the Venezuela. And what we did is that we plot on this graph. So the blue line is still our satellite activity, and the red line is the Venezuelan GDP according to the Central Bank of Venezuela. And what we can see is that it tends to follow quite closely the evolution of the cement plant activity tend to follow closely the evolution of the GDP. Of course, we cannot be completely sure that the correlation really is strong, because we don't have value for the GDP after this date. And since the satellite were launched in 2016, we can't have satellite data before. But for the sample, the period where the 2 samples coincide, we can see that it tends to be a quite significant correlation between these 2 series. So to conclude, we developed a new indicator in quasi-real time with a global coverage of homogeneous data independent from the state. So we can apply this methodology to any country to study the different events that occur. And it allows for a detailed monitoring of activity in the construction industry and in the economic activity more broadly, as you have seen. And it's something also interesting is that it could allow for study of regional economics. It's notably the case for big countries such as the United States or China or India, because you have a very huge amount of cement plants, so you can split it to different province or region and study their difference. So thank you, and if you have any question, feel free to ask.
Okay, thanks a lot, Benjamin. Are there any questions from the audience? we go back to satellite, but on a more let's say precise special item, which is a cement production. Oui, Alexandre, there is another person. And Benoit, yes, please. Par contre, on vous entend pas bien. Hein. We cannot hear you very well.
What's to start? Maybe I can start.
Oui, Benoît, oui.
Yeah, okay. Je dis, on est en français ou en anglais? I don't know.
You can switch to English.
Switch to English. Sorry. Okay, so something which is striking me in your results is that everything seems to be highly seasonal in your results. I mean, that did you compare seasonally adjusted series, or it's really raw series which includes seasonality?
So yeah, thank you for the question. That's a very interesting question. So for the result that are in the paper, so this kind of result, the data we take into account the seasonality, and there are deseasonalized data, so it's okay. But for this graph, it's actually the level data. So with this very important seasonality, mostly due to the weather most of the time, because the construction activity is much lower when it's cold. So that's why there is this very important seasonality.
Okay, so my question is that, do you think that it's not only a partial information, for instance, that the construction sector will partially correlate to the GDP, but not perfectly because of this effect?
Of course, for many different countries, that would be the case, but the closer you go from the equator, so that's the case for the Venezuela at the end, the smaller the impact of the different seasons. So this seasonality tends to erase for the country close to the equator. But of course, for European country or North American country or South Africa, there is a huge seasonality that wouldn't correlate perfectly with the GDP.
So, thank you.
Alexandre, I think you had a question too. Alexandre? No, perhaps there is a problem.
No, I didn't have my.
Okay, sorry. Perhaps it was your hand that was still raised after the previous question. Okay, sorry. Okay, so thanks a lot, Benjamin, for the presentation. It gives interesting insights for the emerging countries with this very particular topic. Being given that we could also do the same with other activities that have an oven, which is, for example, steel or glass. So the combination of the three could indeed enable a nice tracking in real time, including for emerging and European countries, for which infra-annual data are for the most missing.